Welcome to the afternoon of the first day of the PASS Summit 2019. I'm really thrilled you're here. You made it out to join us this week, and I'm very excited you're joining me today for this topic. It's something I'm very passionate about, keeping databases running, although I really don't trust the kind of systems they run on, and sometimes we fight with them. But we need to keep all of our data secure anyway. I'm of the mind that there are really two types of DBAs in this world: those who have dealt with corruption and those who will. Who's in the first group? Good, good, good. So you'll recognize some of the errors, but the rest of you, you're not there yet. That's great. This is what we like to do ahead of time. Being prepared, coming to the session before the stuff goes wrong. So let's get into it. Let's hit the right button on the mouse. First, let's not embarrass ourselves. The usual, let's all silence our cell phones. I've been harping on the summit. It doesn't stop. At the end of this week, all of what we do here, a lot of these sessions, we carry around the world. 24 hours of PASS, free online events. We go to our local chapters, SQL Saturdays. I've given this session in some of your hometowns. This is an expanded session for the summit, but there's plenty of opportunity to meet, hang out with more of us out there in the world once you're away from the session here this week, and continue your learning and be a part of it. I'm a DBA. We're discussing our two classifications there. But being a DBA as a professional carries a little weight. It means something specific to me. First and foremost is that I am a steward of my customers' data. That's not my data, but those are my databases. And it's a professional promise that I have made to the owners of those data in those databases. I will take care of them. That's what I'm here for. And if I don't take care of them, there can be some very bad effects. Pretty much every company in the world is a data company. You're not a manufacturing company, you're a data company that makes things and ships them. You're not a hospital, you're a data company that helps people. And if you don't have that data, how many of your businesses can continue? And you really don't need to lose too much of the right kind of data before, oh, we need to stop right now, and bad things can happen. Whether you can't continue business briefly because you don't know who owes you money. You don't know who you have to pay or regulations you need to send out stuff for. You can lose some key things in closing the doors and reconstructing that. Sometimes just the fines and loss of business alone, even though if you can get it all back, is enough to close the doors. So as I'm working for this company that I'm taking into the ditch, this can ruin my entire career, not just the one place where I'm working and cost me a job. Because if I bury a company, I'm taking a lot of people with me. And they're going to go someplace else in my hometown as well, and they are going to know my name. As DBAs, it does not matter whose real fault it is when that data disappears. Can't say, well, they never approved all the backup systems I wanted, so we didn't have one I could trust. That's not the bad news that'll echo through the company. It'll be the DBA didn't back up that database. So my butt's on the line too, and personally, I work for a really big company. If I deep six a database, it's going to be on news sites in 20 languages around the world in 24 hours. So I get to go to bed with that every night. So keeping databases running is very important to me, just putting my foot down and saying, data loss shall not occur on my watch. I will take care of this data. So, enough of the dark introduction. Hi, Eddie, I'm that DBA. I've been in the SQL Server world for a while. Don't want to get into specifics, but it started out before the turn of the century. Along the way, I've become a certified master, which mostly was just from dealing with my current position, where I've been for a while, this massive 24/7 SQL Server estate. Billions and billions and billions of transactions a day. So we get all the challenges. We get to see how to keep these things running. But it turns out keeping systems running in a massive, crazy, billions and billions of transactions a day environment, we use pretty much the same techniques that work in every environment. Very similar commands, very similar approach. So, sharing some of that with you today. This word corruption, what are we going to talk about? First, we're going to define it. What do I mean when I say corruption, and what does it mean in the sense of this talk? How do we detect it? There's different kinds of corruption, and how do we see it? There's different ways of finding it. Once we know, oh boy, something has gone wrong, how do we measure the depth of it so we can begin preparing a plan for repairing it, for recovering from it? And then, specifically, we'll get into how to fix it. which includes today the 2 most advanced commands you will ever need to repair a database. I will include that. And then we're going to break databases and use those commands. That sound exciting? Is that what we're here for? Okay, good. Let's get going. So, corruption, the use of this word. In this context, what do I mean? I classify corruption really into kind of 2 categories because they're caused in different ways and there are different results. The first one I kind of call logical corruption. This is the case where a user sits down at terminal and executes command, and the software does exactly what it's told to do, but the user told it to do something they should not have. For example, forgetting a where clause on a big delete statement. The database is not in the way we want it to be, but as far as SQL Server is concerned, it is a 100% consistent database. It's going to come back and say, look, I deleted all those rows for you just like you wanted. Isn't that great? So this is one type of corruption, whether it's a user error or some software, just a bug in there that something was off by a decimal point. And then there's the other kind, physical corruption. This is the stuff that comes up behind us without expecting it, loss of hardware, so on, where the user goes to execute a command and SQL Server says, I am unable to complete that because some or all of the data is incomprehensible or inaccessible due to problems with hardware. These are both bad states. These are both effectively lost data, and we need to get back from both of them, but they come and go in different ways. So, corruption, as we see it, logical and physical. Logical, just your basic incorrect data mods, missed where clauses, an angry employee you forgot to kick out of the system. Physical could be file damage, failed hardware, something went wrong with the SAN and a few too many drives died at once, or there was a bug in the storage, or a write cache flipped out and it didn't fully persist everything, incomplete writes. Do we see the differences when I'm talking these 2, or any questions about that, or a third type of corruption anyone would like to bring up? Okay, good. So, detecting it. These are 2 different ways. Logical corruption, this is not really something the server is designed to help you find because, again, it's software doing what it's supposed to do. So you're kind of on your own here. How do you know if you have done something to your data that you should not have done or a user did? For very critical tables, we can put things in place. Sometimes we use cascade deletes or preventing cascade deletes and use parent-child tables so someone can't mess up a parent. Putting triggers on key tables. Hey, don't change this unless you're coming from this role. Temporal tables. So when in doubt, you can go back to a table and say, well, give me the data in this table as of a specific point in time. Temporal tables can help us roll backwards. And then also using the SQL audit feature can tell you what was changed, and you can use that to put things back. For the most part, you're going to have to get defensive about this stuff, and a lot of it is software testing and just keeping users safe. Don't put them in a position where they can destroy your data. Now, physical corruption, on the other hand, there are a variety of tools available, and SQL will seek you out when these things are found. First, to give SQL a fighting chance to find it every time, be sure you have the checksum page verify option turned on for every database, every time. Now, if you've been making databases on editions of SQL Server since at least 2005, maybe 2008, then any new databases created will have this turned on by default. You can always go check. Other databases that have been upgraded from prior versions of SQL Server over the years retain the settings they had. So even if it came from SQL 2000 or something like that, where the checksum option wasn't available, it wasn't turned on, if you continue upgrading all the way up through SQL 2019, that won't be on. But you can turn it on. It's actually one of those very safe things to do, very low overhead to use. And when you turn it on, it's not going to go quick rewrite your database and put checksums on every page. All it's going to do is say, from here on out, every page I write will have a checksum on it. So always do this on every database, so every time SQL does a read, it can determine whether or not this is a corrupt page. Yes, question?
Two sort of related questions, I guess. Because like when you're building a database with the Visual Studio database project, by default it says none, which is dumb. But so you flip to checksum, but there's always the third option. I forget what that is. What was it?
Okay. So the question is, in Visual Studio, building using the database tools there. Yeah, database project. I guess the default is to have that turned off. Page verify option equals none. Oh, that's bad. Fix that. Change that. Checksum, this is the exact word we're going to use. And the third option, there are 3 options with this setting. Page verify can be none. Page verify can be checksum, or the one in the middle of the road from SQL 2000 is called check bits, torn page detection bits, that's it. So a checksum verify is a full 32-bit checksum across the entire 8 kilobyte page. And the torn page detection bits are only 2 bits that it calculates on some of the page. So we say checksum because it'll actually inspect the entire page, and that torn page detection, you can get false positives and false negatives on that. So.
And at this point, why do we even have options for the other stuff?
So.
Why is it not just by default when you restore a database to SQL 2019 or whatever, it has checksum?
The question being, since this is the best way and we should always do it, why isn't that like stamped in by default? And so whenever a database comes in, restore a database, it's going to do us the favor of putting that there. Well, backwards compatibility says don't change stuff. That's it. So when you bring a database in, it's only going to upgrade those things it absolutely has to. So that's why the older databases will retain that, but newer ones. That is unfortunate that the project sets that by default. So I strongly discourage that. Make that change every time you do that. So thank you for bringing that up. Other questions? Okay. So when SQL then discovers this, there are 3 errors based on corruption: 823, 824, and 825. These are different things. 823, file not available. 824 is corrupt page, and then I forget which one of that 825 is. But these 3 errors are high-level errors. They'll be raised. You can catch them with agent alerts. They'll be written to the Windows log, and they'll be written to the SQL log. So these 3 errors, 823, 824, and 825, we should set our systems up to keep an eye on them. Because when they happen, we've got problems, and we should address them immediately. There's also a table in MSDB. This table is called dbo.suspectpages. Whenever SQL Server encounters one of these bad pages, if it's something it thinks is corruption, it's going to log it. You can go to any of your systems today and query that table and see if you've ever had any of these types of corruptions. And if you do, what I also encourage you to do is go to the Books Online page. We'll look at that while we're doing some of the demos, because there's a state information in that table as well that tells you why that row went in there and anything that's happened to the row since then. So here's something you can actually, when we're out of session today, the next time you plug into your systems, you can just go peek through there and say, hey, have you seen anything, Mr. SQL Server? Here's a very key point. This corruption detection of SQL Server happens on page access. And if you don't access that page, you can have something that's a mess, but will just lay in that database for a very long time. You can back up a corrupt database without errors. You can restore a corrupt database without errors. You can have a big old black spot in the middle of your database and keep it around for years without knowing until all of a sudden an audit comes in and you go to go try and find that data and bad news. And now the last backup that had any of that information on it is from a long, long time ago and has wiped off. So we do need to watch for it. One way to think about it is think of, say, an encyclopedia. See some younger faces out there. Everyone know what an encyclopedia is? It's a book with stuff in it. So in this encyclopedia, there's articles in various places, and it's not the kind of book you read cover to cover. I'm going to go look up something. Oh, let's see something on Mount Everest. OK, I'm going to go here. Oh, Mount Vesuvius, go here. But it turns out some years earlier when someone was working with this, their pen exploded when they were researching the Grand Canyon. And now all those pages have ink all over them and they can't be read. Now, if I'm never going to read those specific pages, I can continue to use the rest of this encyclopedia without problem. But then one day when I need that, that's when I'll discover it. So this not knowing whether or not it's out there raises the common advice that comes up that says you have to run CheckDB on your databases. Because the kind of corruption that raises these errors can happen on completely idle parts of your database. It's just hardware that gets weird sometimes. So it's like, well, it worked last week. Okay, it worked last week. But this week, might be a different story. So, CheckDB, we like to run and inspect and make sure things. Yes, question please.
If I do regular index rebuilds, let's say on the cluster index itself, for example, wouldn't it read all pages and detect corruption?
If you do frequent rebuilds and you're constantly massaging your data, would that detect corruption? Yes, it would detect on that index that you're actually reading, because it's going to go ahead and read all of those pages in. And even if it doesn't, for example, say it's building a non-clustered index off of something else, if those pages are corrupt, it doesn't care. It's just going to build it and drop the old one. So yes, re-indexing is one way of going through and modifying everything, because it will read everything. CheckDB is better, but yes, question please.
Yeah, I think, but when people use partitioning and they only rebuild the partition they're actively working on, and old partitions are, untouched. You can rebuild only the last partition you're actively working on.
Yes, and if you're using partitioning, so you rebuild one old partition and then you just leave the data in there and then leave it around for a couple of years and just backing it up on occasion and so on, that's absolutely a place where the data can get stale and you can have some disk rot. And yeah, if you're never going back and remassaging it, you won't know, so you'll have to check DB or inspect it other ways. So frequently reading your data, you're frequently checking the checksum on your data. If you're leaving it idle, you're giving it an opportunity to get stale. That's all we have there. So we've detected it, either by a user screaming if some data is missing, the logical stuff, or we've received one of our errors, 823, 824, 825. Well, now people are screaming, got problems, sites going down and so on. It's time to get in and triage this and figure out what's going on. Now, a quick discussion about the files that SQL Server uses, at least the main files it uses while it's running and storing your database. The data file structure, all files are kind of built the same way, in that once you create a file of a certain size, SQL Server will carve it up into 8 kilobyte segments, starting with the first byte, first 8 kilobytes and so on, and call each of these 8 kilobyte segments a page. It then just numbers them, starting at page 0 and rolling forward. Any given page, any given 8 kilobyte chunk, will only hold one specific type of data, whether it's one specific type of metadata, or whether it's for one particular table, it would hold data from one level of one index for one table. So if you have a table with 2 indexes, the data is going to be spread across a couple pages. And if you have several pages, any one of those will only hold data for one table's single index at a single level. Some of these pages within the file have specific purposes, these metadata purposes. For example, the very first page, it's known as the file header. There's some data in there about the file. And then we'll have a couple of pages up front. We get our first page free space page. It's used for tracking blob stuff on pages that follow it. Some of our system pages, the GAM and the SGAM, the global allocation map and the shared global allocation map. These pages are used to track information about other pages in the file. We don't really need to know how all they work or anything, except some of these pages are SQL Server's pages that it uses, and then most of the rest of the pages are our pages, starting with the first extent. It manages them in chunks of 8 pages. Those are data pages, but mixed into those data pages are the occasional system pages of PFS and GAM and SGAM and the BCM, the DCM, and all these other things. This will matter in a little bit. So data files, just chunk. Now, SQL Server makes no serious effort to load up a file from the front. So if it's going to write 20 pages into a file, it might scatter them all across the file. There's no, everything needs to be in order. It doesn't try to keep your table all next to itself. It's just casting things everywhere, and it knows how to find it. So, data files. The transaction log works differently. It's a single file. Even on your largest databases, one file is enough. As opposed to data files, the transaction log, that's a single stream. Or in 2016 and forward, it's a single, you get one stream per NUMA node. But basically, it's a stream. It is a sequential record of everything that happens, every change that happens to that database. Included with that change is what is necessary to make the change, and the undo portion, which is what is necessary to back that up, to undo it if that transaction rolls back. And each of these little changes just gets written into the transaction log in order. Containing undo and redo. So it's writing in the transaction log, say it'll write a record quick, I'm going to begin transaction number 1, I'm going to add a row to page 3203 and some information about that. It's just chunking each of these little records in there. Start another transaction, oh, that's a delete transaction. It's going to start logging all the different things that delete transaction does. Had some more updates going on that first transaction. We had a commit on transaction 2. Things just keep happening here. It's just an order of what SQL Server is doing to change that database. Starting with, if we rolled this database back to the moment at which that begin tran 1 starts and replayed these exact steps as they are explained in the transaction log, we will simply redo the work SQL did on that server. So the transaction log can be used to redo everything we did on that server in order, in exact order, in the same way it did it, to the same pages and so on. It will make the exact same changes. So it doesn't track, selects or anything like that. It doesn't track what kind of query was executed in order to make these results. It's just, this is what I did. And as the transaction log fills up, we take a transaction log backup, which is really just take all of those things in order right out of the transaction log and blow them into a file. Once they've been written into that backup, they can be cleared out of the transaction log or marked as having been backed up, and then the log will just continue to roll back around to the front, starting another transaction and continuing to write. So with this circular aspect of it's just a continuous stream of change, 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 and our transaction log backups, it's just separated into pieces, every so often when we back it up, it's just that complete list of changes. So we can use this if they are in order, and we have all of them. Replaying that transaction log is how we can redo what was done on a database. And that's how we pull off some of our recovery techniques. Questions on the transaction log?
One question.
Yes?
You mentioned about NUMA nodes. So are you saying if we have 2 NUMA nodes in our server, it's better to have 2 transaction log files?
Question is, if there are 2 NUMA nodes, is it better to have 2 transaction log files? That is still no. Just have the single file.
Because you mentioned something.
Yeah, it's I/O streams. So it's an internal concept. I probably shouldn't have said that because I veered off course. Sorry about that. Didn't mean to confuse. So how those files work, they work like that. So then now that we've seen it, or we know what we got to do. We got our error. Let's go see what actually happened to the database. Measure the extent of the damage. We do this with dbcc checkdb. Now this is a big piece of software that does a lot of work. It'll inspect quite a number of things in your database to make sure everything's good. It's not just looking at each page. It'll look at the rows on the page. It'll make sure all the links are correct. All of the indexes and pointers are all proper. So it can do some work, and it can take some time. Get used to this before you need it. Restore your databases to another location and run checkdb against them, preferably frequently, because you need to know what it looks like. How long does it take? Often once our systems are down and people are screaming and it's like, I gotta let this command run. If you've got a bigger database, it's gonna take some time. And it's like, well, if it's gonna take an hour, it's gonna take an hour. If you know that going in, you can explain it to people. But if you don't know what it's like going in, it's like, I have no idea how long we're going to run here. Yes?
I just noticed if the instance is starting up in the error mode, I get a message like dbcc checkdb finished with no errors, but obviously it's not checking the whole database. So what does that portion of checkdb actually do?
Question about the startup message. When you start up your databases and it goes through recovery, you're going to get an entry in the log that says dbcc checkdb completed with no errors. dbcc checkdb has many options. Some of them dig a lot further than others, and the startup check is a whole lot less of a full database check. If we had to go through a full checkdb on every database startup, there would be lots of sessions on how do we turn that off. Because it's like, just get it running, then we'll see. Let me log in. And that's another part of getting used to checkdb is going through the help file and all of the different options. It could be its own session. I've been to very long sessions on checkdb. about performance tuning it and getting it to run quickly. The more comfortable you are with this command away from a disaster, the more easy your life will be in the face of one. Now, some of the reasons we let it complete instead of just throw everything out, we got an error, we're going to restore a database, is because of the way that damage hits, you never know. I mean, it's scattered around the file. It could strike parts of your database that don't really mean data loss. For example, if you lost part of a disk, but all it got were non-clustered indexes, did we lose any data? No. We can rebuild those non-clustered indexes with data we already have. So we can just take it live. We don't even need to go screaming at the tape people to get us some database backups. So run it completely and let it and then analyze it and figure out where to go from there. Yes?
Actually, I imagine you could also have corruption on system pages like GAM or PFS. Would that be more severe than corruption on data pages, or is this going to be there?
Question, we're getting a little ahead of ourselves, but so the corruption that gets us, I mentioned it could just be on a non-clustered index, which is simple. We rebuild the index. It could also occur on data on some of those pages I was pointing out when I was mentioning the file. If it happens on those, we can still recover. We have fewer options. That's the main idea. And partly why we let CheckDB go all the way through, because it'll tell us, by the way, some of what got damaged here, you're not going to be able to fix by hand. Or at least, you know, a nice, simple, single-page fix. So we'll talk about that fixing right now. So this is the line. A backup never saved anybody's job. If you are backing up your databases and not testing them, you cannot look me dead in the face right now and say, I trust my backups. You're probably just wasting electricity. It's easy to take a backup and have it work, right? Well, the job ran. I ran verify on it. It said it backed it up. Is that a backup you can use to recover in the scenario you want to recover from? Did you even take it right? Did you get all the files in there? Is it going to a null port? It's like, well, yeah, I backed it up. It says it's 3 terabytes, and it was deleted immediately. Read the news. That's happened to places. We get it all backed up, and then it goes right out the door. So a backup never saved anybody's job. The restore did. So what we're here to do and talk about is planning for the restore or the repair. In order to pull that off, what we need are options. We need flexibility. Got to be able to get at my data through a variety of means. So our restore options, let's talk about different ways of getting data back from SQL Server. If we've been taking our backups, we can restore a full database. Just straight up say, okay, this whole thing's shot, or I want to put it somewhere else. Say I'm setting up an availability group replica. I can just go from 0 and get all the way to a full database. If I'm using the full or bulk log recovery models, then when I restore that database with my transaction logs, I can set that to stop restoring at a specific point in time. You've got this stop at, and you can use a standby restore. So in some of our logical deletion scenarios, we've lost some data, well, we know when the command ran. So I'm going to restore my database up to half a second before that command ran, put it in standby mode, and then I can select data out of those tables that were damaged. It's kind of all the better you can do. You cannot lay parts of a table on top of a running database like that. But we can do a full database. We could do a partial database if we're running the Enterprise Edition. And this is terrific if you're dealing with very large data sets and a need to recover to another system quickly. With a partial restore, all you need to get running is the primary file group. Once you've got the primary file group online, you can bring the database online. Any data that resides in the not yet brought online file groups are not available. You'll get errors on those. But you can get the primary up and begin adding file groups. When we work with very large databases, I work with really big, stupid databases, parts of these databases, there was a mention earlier about folks using partitioning, parts of these databases aren't necessary right now to do business. So if I lose this thing and I want to get it running somewhere else quickly, I don't want to restore all of the history just yet. I want it all back, but not right now. Let's just get back in business, and then we'll get all the reporting put in. With a partial restore, you get your primary file group online, and then you can add in one or other key file groups that have the Right Now business and bring those online, and now part of your database is functioning and people are doing work. And then you can start restoring the rest of the database. We have some questions.
How does that work with foreign keys?
How does that work with foreign keys? Well, when we're storing part of a database, what is available is what gets restored. So if you've got foreign keys pointing at a table in a file group that you have not yet restored, then you're going to have problems reading the table. So you need to have that data available. But if the file group you restore has both primary keys and their foreign keys in the same file group, then it all works once it's online. Next.
Yeah, I was just want to add that your application has to deal with that as well. The home tables are there. Mendoza did a great blog post about Stack Overflow, and they are linking home mode, so they will even show the web page if they only read from the database. But that's pretty advanced thing. So that's not what, for example, my developers can do out of the box. And then you would have that thing. But it's an interesting thing to look at.
Yes, absolutely. The comment was about having the application understand that not everything is available. So if you've got a scenario where a web page shows not just what the user's currently working on, but goes and pulls up a lot of data about history and here's some things you've done in the past and gets it on there, you've got them the stuff they could do current work, but your application just might not be ready for it. So yes, having an application that can handle that too. Question? In what version of SQL Server? This 2005, 8. It's been around for a while. Yeah, I'll say all supported versions. I should be covered there. We're all 100% on all supported versions, right? Not a lot of hands. Okay, so on some recently, maybe not yet, still supported versions, this works as well. So then we'll bring part of our database online. And again, we get the partitioning bonus on this, so we've taken our huge tables and we start, in different file groups for the old stuff. We can leave that behind on a partial restore. Corruption fixes. This is the fun part, probably why you're here. We've got a running database. I don't want to just dump it and do a restore from backup. We've got the database running. People are in it. If it's Enterprise Edition, you can do this while people are in it. We're going to restore damaged files, or repair them rather. We can repair damaged pages. You got a great big 5 terabyte file. I'm going to go in and do surgery on 8 kilobytes and get out while everyone else is using the rest of that file. We could do that. We're going to play with that today. Love this last line. You're running availability groups. A lot of the page kind of damage we'll see. Automatic repair. If you've got that checksum running. So when you go to read the data, it says, oh, wait, there's a problem here. I can't read it. The user will get the error, but if they retry that query, it will work. Because as soon as it throws that user out, it will make a request of one of the secondaries and say, hey, I got a problem on one of my pages. Can you give me your copy? That's the nice part about availability groups. We've got copies of the database in different places. Even if we never fail over to that other one, just having it there to take backups and have as a lifesaver just hanging out there on the side, but keep it on separate storage so you can take all sorts of damage to your database and just bring it right back up. Question?
The solution doesn't forbid logical corruption because they apply to the same.
Right, so this does not apply, obviously, for logical corruption because in an availability group, as soon as that user commits the change that they deleted all that data from your primary, yes, it's going directly to your secondary. But at the very least, when you're putting the rows back in the primary, they'll automatically go to the secondary, so not total loss. Had a question over here?
So for the AG auto repair, does that only work with index or it works with actual data corruption as well?
The AG auto repair works with all kinds of data corruption. Whether it's just the specific types of data corruption in that a data page, an index page, to any of the pages, so it could be leaf or tree, or like a blob page. So user data of any kind, all works.
Is there a reason that you say restore damaged files and repair pages because you can also restore pages?
Just a semantic question. Why did I say restore file versus repair page? We'll see in the demo, when we're doing an entire file, we're going to replace the whole file. So that's just restore, and we're going to stamp all over it. And I say repair because, yes, we're doing a restore, but it's almost all intact. We're just fixing a small piece. It's semantics. It's restore is the command, but it's just, we'll use all that. Any more questions on the kinds of options here? Okay. How are we doing on time? Phew. So, in order to be able to recover from a variety of times, I'm proposing for my setup that I'm going to back up like this. First, one will be in the full recovery model. Just save our tails there. We'll take a full backup. Now, when you set a database into a new recovery model, whenever you switch models or the first time you create a database and put it in the full recovery model, you can only take a full backup. Obviously, we cannot take transactions log backups yet. They have not been initialized. So we'll take our very first full backup, and then we'll start taking log backups. We'll backup log to disk, and also, because I'm running the Enterprise Edition, unfortunately this is Enterprise Edition only, I'm going to mirror my backups. When you back up a database, back up a log, do a diff backup, you have the option of also specifying mirror to. So as I'm writing one transaction log backup out, it will be simultaneously writing that same backup to someplace else. I'm going to send that to a completely different array. So if I lose an array, I keep my backups. I don't trust anything, I'm a DBA. So we're mirroring our backups. And as things go by over time, I'm also going to introduce differentials. Keep taking logs and keep taking fulls. Now a bit about this, these differentials are labeled. I took my full A, the next full I took I called B. Differential A1 and differential A2 only apply to full A because they're just the differences since that full backup. Same story, we've got B here, so its differential applies only to B. Now the reason B1 applies to that full on B is that I did not take it with the copy only flag. Had I taken full B with the copy only flag, then that differential B1 would say diff A3. The copy only flag does one thing. It does not reset the differential base, the fancy way of saying it. Basically, it says when I take this full backup, make it so the diffs still work with the previous full. Don't change that chain. Full backups do not in any way affect the log chain. I've seen a number of confused questions on boards, but I can take fulls, if that full B copy only, not copy only, doesn't matter, that stream of logs is still good because I can recover this database with, as long as I didn't interrupt that log chain, with any full that's been taken. Take any full, its most recent diff, if it exists, and every transaction log since then. In this case, if I want to do, say, set up a secondary, I want to restore from some backups first, I'll go to full B, I'll get its most recent diff, and then because the two log streams are copies, I only need the logs from one of them. So I'll do that. That's if I have a normal scenario. Then the abnormal scenario is, hey, Eddie, problem, this database is now a mess. We need to do a restore and we need to do it quickly. An actual rack caught on fire, and those disks are gone. Poof. Okay. And it turns out, in that same fire, that got rid of some of our backups. It torched that full, which makes that diff kind of torched as well, and it was a little too close to where these transaction log backups were taken. Now, if those full and those logs were my only copy, I would now be kind of stuck. I'd have to go further back in time and couldn't come forward. But I do have a mirrored set of logs. So I can catch this database up to current with any full, its most recent diff, and all of the transaction logs since then. So losing some of my backups doesn't mean I lose any data at all. It just means I might have to look somewhere else for data. Any question? Yes?
What is the point of doing the differential if you rebuild the thing from the log backups?
Question being, why would I ever take a differential if I could rebuild things from log backups to begin with? Anyone care to answer?
RPO, RPSE, you want to lose like 5 data, take
Yep.
this under 5 minutes.
I hear RPO and RTO. The differential is the result of all the changes. The transaction log is the list of instructions to go and make them. So like going from restoring this transaction log and these 4 here, as opposed to just applying this diff, there could be cases where I was updating and updating again and updating again, and the transaction log could be modifying pages not necessarily in order. But the differential backup just goes through the database and will copy pages out that have been changed. So it's just going to rip through an order of your database and lay them back on. So in many scenarios, if we're trying to recover quickly, the differential is just a time saver. So it provides the same result, but we're into saving time. And especially if on busy databases, we could have very frequent log backups. Anyone doing like 5 minutes? So yeah, take a diff once a day as opposed to restoring that many logs. It's just easier to type, you know. we seek to make our lives easier. Question?
No, I just wanted to add, in my opinion, it's also reducing the number of moving parts. So any one of these files could get corrupted or damaged, and if I have less of them, the chance of failing is less.
Oh yeah, I love that thinking. It's by having diffs, one, we've got another way to put this database into the state we want it. And it's protection from, hey, what if those log backups got trashed? At least I can move this far. Yes, that's DBA thinking there. Because everything fails, okay? Everything fails. I work with a large system. I see lots and lots of stuff. Everything fails. What happened here?
Everything fails.
Not everything, just some stuff in the middle. So kind of like before, I've got my fulls, I take fulls, but I go look at my history and I noticed all of a sudden my jobs failed for a little while and I couldn't get log backups, and then I'm getting log backups again. What could have happened here? Could have been a big log file is one suggestion. Anything else? Ran out of space, that'll do it. But I didn't run out of space, I'll just say that. What happened here is someone said that log was too big, so I'm just going to put it in simple mode and put it back in full so I don't have to deal with it. And when you change modes, transaction, so it was shortly around the time of diff, differential backups still work, that's fine, but the log backups no longer work because I changed modes. I have to take a full to start that over again, and this log chain is broken. There's no history for what happened in there. So if we had that disaster I described, that took this full and this diff and these logs, and I need to restore to now, I'm kind of stuck, right? That's all the further I can get. So protect that log chain, which is why I like mirroring it, getting lots and lots of copies. Yes?
Usually if I had to do that, throw it into simple and I issue a check. Does that matter?
Is it bad? Now, to go ahead and do that technique where you're going to go ahead and switch it in simple, throw a checkpoint and get it out, is that bad? It will not damage your database. I am not going to give advice on how to make that trick work. Take a backup. Just take a normal log. True. Checkpoint, so it's in simple recovery, how do we get that log to go? Sometimes issuing a checkpoint. Another issue you deal with in the simple recovery model for flushing out a transaction log is it cleans it up when it wants it to, or when it wants to, and it doesn't want to until it gets 70% full. So you're 60% full, everything's committed, why nothing's happening? Well, get it to 70% and it'll clear. So it looks full, but it's not. Yeah, it's fun a simple model. Hey, let's break stuff. Demo time. Question?
This may be out of scope, but I support SharePoint databases, and they by default come in simple. Do you have any opinion on whether they can stay simple or whether they should always be moved full?
Questions on SharePoint are touchy questions. So as a question, the SharePoint databases, by default, I guess, set themselves up in simple. Gosh, I don't know.
I've always done it just because that's our policy, but
It would be one of those, I would ask if it's supported to run it in full. Because many folks just in your basic SharePoint farm might not, it's like we're just doing some things in there, we're not really leveraging it, so they're not as serious. And then if so, then you can do normal backups. I would just ask if it's supported. I'm sorry, I don't know. Does anyone know, is anyone running the full recovery model on a SharePoint database? We are? Seems like it might work. Are we on time here? Yeah, there were some questions? Yes?
Yeah, going back to the mirroring functionality.
Mm-hmm.
For logs, can you mirror more than once? Like you mirror like 3 or 4 times if you want it, just to be extra careful, and you mirror to a URL instead of the disk.
So the question is on using the mirror to feature of backup database. How many targets? You can have 4 targets. So backup log to disk and then +3, or backup database to disk, +3 mirror to statements. And can you send those to a URL? Yes, they're targets just like it's just a backup target. So if you can fire to it with backup disk to X, then you can mirror to X.
will that work for the log shipping?
Will that work with log shipping? Absolutely, because log shipping is just backup database, restore database, right? So if you add that to your log shipping, then you'll just have extra copies of your log. They're not being shipped, but you've got extra copies in case the log ship part, those folders fall apart and you want copies. So it won't break it.
I guess, kind of bouncing off the SharePoint question, does changing the recovery model break anything? Either direction? Why is it a problem to switch from simple to full?
As I am not a SharePoint person, in any, what problems could happen if I've got a database in simple and I just up and set it to full? The only real problem we run into is if you aren't taking transaction log backups with some level of frequency, then the log fills up, the disk fills up, the database stops changing. That's
It doesn't affect the application at all as long as you change your maintenance solution to adjust for that.
correct. It does not affect the clients in any way. They shouldn't see anything. It's just how can we fix it after it's broke? Yeah. Wow. So someone experienced a case we're putting with an application that did die on that. So I stand corrected. I don't know the specifics.
But the first time a user tried to really crunch the numbers, it's just a joke.
I wonder if they forgot to close the transaction and just killed itself. I don't know. We'll stick with my general statements and hope we all don't have to deal with that application going down the road. And I'll just say there is someone else named Eddie Wuerch who programs software. So if that's what you saw as the person who wrote it, it wasn't me. Oh, yes, let's do some demos now. We're going to break and then repair non-clustered indexes. We're going to do some corruption of clustered indexes. We're going to smash some data files, and we'll talk about recovery and availability groups. So let's get nerdy. Okay, so I'm going to be using this database here I'm calling recovery demo. Let me just rebuild this real quick. My screen's getting all weird. I want to build that from scratch. And expect those errors. So this stored procedure, I haven't uploaded the scripts yet, but they'll be there. We do need to talk about this. This stored procedure uses an undocumented command called dbcc write page. This command exists for one reason: to corrupt a database so you can fix it. That's it, okay? Yes, you can do very specific byte-level writing on pages with this, but you can't fix a database with it. If you're hearing about it from me, you don't know the rest of the details. So this command, again, there is no risk, and this is the message it's going to say if you grab it and try to run it. There's no risk at all. It will destroy data, okay? There's no chance you're walking away from this with a clean database. Also, it does literally void your warranty on that database. It is a contaminated database. So, you bet I'm using this. Haha. Okay, so that's going to help us tear up databases. All right, so let's do this. Start with, I have my database. I put a table in it with a little bit of simple small data. So we'll start with backups. I've got my disk here that I'm backing up to. So first, I'm going to look inside this database. I'm going to look for a page to destroy. Page type 2, you're an index page. File 3, page 24, and I'm going to execute my little command. Now what this is going to do is write some random bytes onto that data page. This is a data page that's part of my table. It's part of my non-clustered index, and it is no longer whole. So if I try to look for my table, look at my table, I'm going to have myself an 824. SQL Server detected a logical consistency-based IO error incorrect checksum because I have a checksum mode on. And it's going to say, this is where it happened. Page 324, the error message continues to say, in which database. So I now have an error. Where are we? So if I were to go to msdb.dbo.suspect pages, I can see that I've got database 6, that's this database. File 3, page 24, has had an event type of 2. Let me go pull that up. So the suspect pages article on Books Online gives us for event type 2 is a bad checksum. So we can go and look in that table and say, hey, what have you found if you weren't there to catch the error? We got a bad checksum, so that means, let's clear this out, it's part of the rest of me causing my errors. We're going to do a check DB with no info messages. Let that thing run, and it's going to kick out some errors. Control 1. So here's what we see. We got a table error. It's got an object ID, which is a table, can be turned into a table name. I got an index ID 2. What does that tell me? It's a non-clustered index. So the first thing I do is exhale. No, nothing wrong with the first error. Okay, let's look at the next error. Oh, looks like more errors on the same thing. Also index ID 2, index ID 2. Okay, so we've got this, and it tells me, if I go through this, it's all on page 324. So I only have one small thing broken there, and it's in a non-clustered index. So instead of doing anything fancy, you can see if I want, I could use that object ID and look my table up. It's called tester. I can just rebuild my index, because an index is created by reading the table and sorting the orders. Yes?
You were just talking that you work in a very big environment. Wouldn't it be the case that your index rebuild running for hours, so that you basically go with the way the restoring from backup with that single thing?
Question was, in a very large environment, if I see something like this, would I rebuild an index or would I repair it? Like so many other SQL Server questions, the answer is, it depends, yes. And partly why we let this run, and I looked at the table. What is this going to cost me? Yes?
Disable this index just so that no other plan is utilizing this.
I'm sorry, the question again, please?
If you disable this NCI immediately, that would cause you to remain online so that no other cached plans are using this by default. Right? If there is already a compiled plan that's already using this NCI, if you disable it immediately, then it's not going to.
Right, so as a defensive measure, the point was raised, hey, disable this index immediately before I get working on it. Because anyone attempting to use this index, SQL Server isn't going to tag it, don't run this query anymore. And if we've got some plans sitting in the cache that say use this index, even though you could, it might be a little slow, but you can get your data through other indexes, those queries will fail. So yeah, if we disable it immediately, then those plans will be flushed out and folks will be online while we put ourselves together. So we could just do a disable. In fact, that's the answer, because if we try to just rebuild the index, SQL Server is going to say, oh, rebuild, that means I've got to look at this table's data in this order. I have an index that does that, so I'm going to read that index. That index, of course, is the busted one we're trying to fix. So we cannot use it to rebuild itself. So instead, we're going to disable our index and then rebuild it. When you disable an index, it drops the storage and makes it unavailable as an index, but the definition stays. If we wanted to drop and recreate this index, we need to have the definition. because we're going to nuke that definition. So I like rebuild this, or disable, because it's just do this. So we'll disable it and rebuild it. And with just that rebuild, now I got my data back. Nice boring table, but all the data is there. Yes?
What's likely to cause that nuisance?
What's likely to what?
Cause your index to be corrupted the way it is?
What is likely to cause this kind of thing? There can be a variety of things. Generally, when we're dealing with, say, a storage system, there's quite a lot of software and hardware between your database and that storage system. So some things I've seen, I will not mention vendors, don't ask. We had a scenario where a write cache was loaded up, and the SAN, we had a power event, and the SAN rebooted 3 times and panicked and flushed the write cache. So it was just parts of file writes were hanging out and never made it to the end. Things like that. Or you could just simply have disk rot. You know, that mean time before failure number you see like on disks, 1 million hours mean time before failure, that doesn't mean it's going to run for 1 million hours. That means if you have 1 million of them, you lose one every hour. And if you have 40,000 of them, you lose one every day. So they die. Various defects and so on. Bad things happen. It's rare, but it's real. I'll just put it that way. So once we've done that, just by rebuilding that index, if we go look at suspect pages, our row is still there. Because we didn't do anything specific to tell SQL Server, I'm fixing this page, all it really did was wind up deallocating the page when it created a new index. So it's just a table. Once we go do our checkDB again and we come back clean, we're just going to delete suspect pages. Clean all those pages out of there, I'm good. So we can start over again. So that's the easy one. That's where we can fix it just by running a simple command. Let's go get some data. Page 3.8. All right. So now if I go to read my table, just selecting order by the primary key, boom, we have ourselves another 824 error. And if we go this time, now we see file 3, page 8. So that's the page I stuffed in there. Event type 2, as we saw before, is a bad checksum. Run our checkDB. And this time, we got index ID 1. And that means clustered index, which is a fancy way of saying data. My data. So this is important. We'd like that back. But I can't select it from anything else in the database. We got to go somewhere else. So one thing we could do is after that checkDB came back and said, this is damaged, what it does say in there is repair or allowed data loss is the minimum repair level. And if we did that, repair allowed data loss with checkDB, what it would do is drop that table. That's the only thing it can do to make it whole again. It's concerned about a running database, and that table is shot, so it can't fix it. Don't want to drop the table. I want all my data back. So we are not going to checkDB repair allow data loss. Do not allow data loss. So whenever we get into our scenarios where we're starting to repair a database, the first thing we do when we see corruption is we back up the transaction log. Because when you see corruption, you could see more corruption soon. You could see more corruption soon after that. Get that log backed up first and foremost. Stop, back up the log. Now address the scenario. So let us back up our transaction log, because corruption that happens to the disk is not corruption necessarily that happens to the transaction log. And when a stored value on disk is destroyed, the instructions to destroy that aren't written to the transaction log. We can use the log to put things back. So let's get a backup of the log. Execute. Now we got a current log of that. So it's just one page. Now here's the trick. Restore database, and I'm adding one thing to my command. I'm adding the page. What this says is start restoring this database, but that's the only thing. We're going to use our entire backup file, but so go fish through that and only find this little thing and put that back. If I wanted to recover a series of pages, I could just put comma, another page, comma, another page, comma, another page. And once I've done that, Excuse me? Question about the database being in single user. This is the developer edition of SQL Server, which is Enterprise Edition. I'm doing this hot, online. And then once I have started this command, on top of the restore database, and I've mentioned the page, you'll see all the following restore log commands don't need any of that in there because the restore set has already been set up. So let's use master. We'll restore it. And once I've done with these, restored those logs, there have been changes in the database since my last backup. So this seems weird, but the more you think about it, it might make sense. We're going to take another transaction log backup and reapply it, basically making sure that any of the changes that have been coming in from these backups are fully stepped on with all of the latest changes. So we'll just back it up again, restore it, do the restore with recovery, and I have all my data back. The commands and the steps I took would be the exact same if I had a database with 400 data files and 2 petabytes of data. Same technique, I can repair the small thing. Question?
So you restore the log for just the page which was corrupt, right?
I restored the logs for all of them, and during that restore, it only affected the page that was corrupted. I still needed to take that last backup and apply it, even if no changes are a direct result in that log. It's just a case of making sure that everything that has occurred in that database has been captured. And
That's concerning other pages.
yeah, it's even though I didn't affect other things, it's just a necessary step to tell SQL that I have brought things all the way forward, that this restore is current. And I'm running short on time, and I want to get through the demo, so let's slow down for a little bit on questions. Make sure we get everything in toward the end. Excuse me. So now that we've done that, boom, I get a nice clean CheckDB. And now if we go to suspect pages, Control 1, we see there's an event type 4 listed for that. Before it was event 2, but because we used restore, we can go and suspect pages, and it's now logged. Hey, I fixed this. So you can go delete that. Clean that back out. Control R. Okay, let's build. I've got an extra file group that is that the data file for it is on a little SD card here on my computer. It's file group 2. Let's put a table on there and put some data in that table. And then have us a problem. So this is drive D right here. And we just lost drive D. Let's see, if we try to do some stuff, we might get a few errors. Oh yeah, it's going. Come on, finish your error. Why is this hanging up? Finished crashing already. You gotta be kidding me. See if that works. Wow, none of the demos. This thing is completely crashed. Come on, stop already. Okay, there we go. Haha, there we go. So, check statement aborted. It's throwing up completely. There isn't even a file full of data to check, so CheckDB aborts painfully. Now, again, I keep talking about the value of these things are backups. We can always get back to a running database as long as we've got stuff stored and we put the... This is just not my day. Come on, man. Well, this reminds me of an event from a few years ago. We did have a database that went under. And the call came in, 2 terabytes were just evaporated from the SAN. And I made the call, I need some backup files. I get the tape guy on the phone and he's like, I don't have any of these TRN files you're talking about. Those were logs, I deleted those to save space. This was a while ago, it's not Salesforce, let's not point fingers. Not amused, because this was the database that ran the company. And without that, we would be in a lot of trouble. I had to look the founder in the eye and sit him down and say, you need to call your family, an attorney, and an accountant, because Don may not come for this company. And it is my sincere purpose for coming to this session is to ensure that none of you ever have to make that speech. Because going on in the background of that speech, we were recovering from our mirrors. Because I'm a DBA and I don't trust anything. And this disk I don't trust either. So I have copies of all my backups that are not on this backup system. So I'm going to go to my mirrors and restore that. So where were we? One page, we can fix it. Oh, let's go a bit further down. Here we go. So select star from sys.database files. I trashed this file here, drive D. It's gone. So I'm going to set the file offline. That will throw an error because the file isn't there, but we're just telling SQL Server. And now when I do my restore command, I'm going to mention the file. This is the logical file name we get from sys.files. And then, let's see, from disk and so on. And I'm going to move my file to a place on C because my D drive is now gone. So if I didn't break all this, and once again, when we get to the bottom, we're going to take another log backup and reapply it, and then we'll put our database in recovery. Did I miss a step? I missed a step. Now it's completely shot. Well, rats. Got too busy talking and missed a step. Okay, so I forgot to back up a log in the middle of all that. Now it's screwed. We'll move on, because basically what happens is just like the last one, it would come back and working. I want to get to the AG demo. I'm sorry we went a little on time, so I don't have time to repair this. So this one would like to show what happens when we're doing our automatic page repair. So we'll do some recovery here. So let's see. Let's create my database. This is on a VM where I've got a cluster going. And we're going to do like we did before. Let's get rep page put in there. Let's get our walkthrough demo up. Create an availability group. What? All right, create database, good. Page. Create AG, then build availability group. Why is this doing this? Suddenly my demo no longer works. That one wasn't planned. This one's supposed to work. Unfortunately, I have nothing but apologies here. Damn. Yeah, we don't have time to repair this. I'm sorry. I don't know why that error is happening. Oh, I'm very sorry. So what I'll have in there, basically it's just creating an availability group. Now the trick I go through with this is, oh, I know what I did. It's to damage the database after I take the backup, but before I create the availability group. Once you've done that, because if you're not able to run that rec page once it's in the availability group, But once I've done that, then you simply can run a selection. And if you select from the table twice, the second time it'll work. I'll have details in the download. And I also include some X events you can run on your server when you're doing this. There are a series of extended events for automatic page repair, as it's called. So if you've got this running in an availability group, you'll be able to take this query here and run it against your systems, and it'll tell you if it's ever done that. Because the auto page repair is just going to be a quick error to the user, and then it'll fix the page. Get back to the presentation. So, document, practice, drill, repeat. Even the demo you tested a million times can blow up in your face on stage. Test, refine, repeat. Again, do your backups even work? Just because you're taking them doesn't mean you can recover from them. And until you do it, you don't know what it's like. Because when it's time to restore, when things are going bad, you're going to have people on your back, a lot of folks asking questions, when is it coming up? Someone will walk by and start writing numbers on a whiteboard. We lost $1 million. We lost $2 million. We lost $3 million. A lot going on, and that stress makes it hard to try and figure out how things work then. You're going to be looking stuff up online. Crises, they don't care. They could happen to us when I'm standing on stage right now. So having your entire team ready for it is key. I'm here, I can't fix anything. Someone else needs to be able to. I've worked with teams where the chaos monkey is a real thing. They just grab it and out of the blue, you restore this database to this cluster to this point in time, go. You keep hitting your team with that enough times, and not only will they figure out where the problems in the chain are, because some backup systems are built to make it easy for the backup people to take backups, but aren't really geared toward getting recovery. So when you go through these drills, one, you'll start writing all the scripts you need to make that quick the next time, but you'll also be sure that things work and that the flow is there to save time. Script, automate, document, anything that can be broken by nerves will be at time of disaster. So the more prep we have, the better off we are. With that, encouraging everyone to, with all the sessions you attend this week, please go to passsummit.com or grab the guidebook app and rate each of the sessions you go to. The event likes to know who they should invite back, and all of us speakers like to know where we went wrong so we can improve. And there are prizes that they're giving out. Get your stuff in by November 15th, and they'll let you know they're giving away some cool stuff. And with that, we can continue to take questions, but thank you very much.